Alright, so here's a question. Find all relative extrema of function f of x 2xy minus 1 half x to the fourth plus y to the fourth plus 1. Alright, remember, we first need to identify gradient points where the gradient is equal to 0 vector. Is equal to 0, 0. Because points where these things are true are called, when the derivative is 0, it's called the critical point. Critical points. And once you locate these critical points, at each critical point, you need to calculate the Hessian, right? So you want to calculate the Hessian at each critical point. And it has three different cases. One, if HF is positive, that means there is no change in concavity as you go around. Therefore, depending on whether fxx is positive or negative, it determines the concavity of the entire thing, right? In all directions. Okay? Now, in that case, you have relative max or relative min. Which one is it? This is the case when you have a smiley face, right? So, at this point, you have relative min. This is the case when you have a frowning face, so it's a relative max. Now, as I said earlier, the Hessian being positive. By the way, Hessian is quantity. It's a matrix determinant of a matrix made by all its second partial derivatives. So I can differentiate twice by x, or once by x and once by y, or twice by y. Okay. So you make this matrix and you take the determinant. If this determinant is positive, it ensures that the concavity doesn't change, so that once it's positive, it's always positive. If it's concave down in one direction, it's always down. Now, what that means is that in some rare cases, trying to determine the sign of fxx is not so easy. So you can switch these statements for fyy. So instead of saying that f of xx being positive, you can say, if you notice that f of yy is positive, then it's a relative minimum. You don't even have to look at the fxx. There are cases where f of yy is a constant. So that constants are very easy to see if it's positive or negative. You don't have to plug in the values, right? So those are the shortcuts that you can take. So instead of this statement that I wrote, you could write fyy, or instead of fyy bigger than 0 or less than 0. That's the case. And then, if h of f is negative, what do you know?
There's a change in the concavity.
Which means it's a point, it's a saddle point. So immediately you say, oh, this is not a relative maximum nor relative minimum. So you take it out of the answer, because it said find all relative extrema. So you're only looking for either this case or that case. If this happens, you don't care. Yes?
So it's a saddle point's a change in concave.
It's concave down in one direction, concave up on the other direction. So it's neither higher than the neighboring regions or lower than the neighboring regions. If you view it like this, it's higher than this direction. But if you view it like this, it's lower than the other direction. So you can't really say it's a relative extreme. Okay? So that's what happens at the center. Okay? All right. So let's actually apply this over here, which means first I have to locate the critical point. The gradient of f is what this is. 2y. If I differentiate by x, it's 2x is the third. That's what I get. And then if I differentiate y by y, it's 2x, and then minus 2y cubed. So therefore, if you want a critical point, I need this to be 0 and that to be 0. 2y minus 2x cubed has to be 0, and 2x minus 2y cubed has to be 0. Now let's see what that means. Let's see. I mean, one easy solution is already visible here. What? If x and y are both 0, then it's a critical number. So 0, 0 is already a critical number. But other than that, it's hard to see. Well, let's try to simplify as much as possible before we do that. Well, you know, it goes like this. You just solve for one of the variables and then you plug into the next. Okay, so if I solve this for y, it's y equals to x cubed, because if you move this to the other side and divide by 2, that's what you get. And on the second one, you get x equals to y cubed. Now, since I have the first one solved by y, I can plug it to here. And then I get x equal to x to the third power, because y is x cubed. It's x to the third power. So we get x equal to x to the 9th power, which can be factored like this. 0 is equal to x to the 9th minus x. 0, because they both have x in there, I can factor the x out, and I get x to the 8th minus 1. So for this to work, either x is 0, which we already knew. In that case, because y is x cubed, y will also be 0. Or x to the 8th minus 1 will be 0. Now let's see what this means. X to the 8th minus 1 equal to 0 will mean x to the 8th is equal to 1. So what can x be? 1 or? 1 or negative 1. So there are two cases. X is 1 or we have negative 1. Now when x is 1, what's y? Because y is x to the cubed. If x is 1, y has to be 1. And if x is negative 1, y has to be negative 1. Alright, that was a little tough, but we managed to find it. So what are the critical numbers? Critical points are 0, 0. When x is 0, y is 0. So we have our 0, 0, 1, 1, negative 1, negative. That's what you have. Then 0, 0, 1, 1, negative 1. Then now we have to calculate the Hessian at those points. At these points. So now let's move on to calculate the Hessian. Alright, what is this again? This is f differentiated by x. That's f differentiated by y, right? So if I want fxx, what's that? Which one do I differentiate by? The first one. By what? X. If I differentiate this by x, I get the fxx, which is differentiating 2y by x, you get 0. Differentiating this by x, you get negative 6x squared. And then if I take fx and this time differentiate by y, what do you get? 2. Just 2. If I differentiate this by y, you get just 2. Because 2x cubed, when you differentiate by y, it's 0, so you only get 2. And then we also know that second partial derivatives commute, so whether you do f differentiated by x first and then y, or if you differentiate y first and then x, you get the same result. So you can always save time by using that. And then, what's fyy? I have to differentiate fy by y, right? So it's negative 6y squared. All right, so now we have the Hessian. What's the Hessian then? Negative 6x squared, 2, negative 6y squared. That's the Hessian. That's h of x. All right, so let's continue the calculation here. H of f is, yes.
Will you ever have a like 3 by 3 Hessian?
Oh, so if you have a function with 3 variables, and if you list all possible second derivatives, you will make up a 3 by 3 matrix.
Solid scaling.
So the problem is once you get to 3 by 3, then to ensure that all its second derivative sign doesn't change requires more than just saying that the determinant is positive. So in addition to the Hessian, you have to say that all the 2 by 2 minor matrices. So if you have a 3 by 3 and you cut off the last row and the column, you get this 2. That also has to be positive or negative. I can't remember which one, but that has to be done. So, but we won't be covering in this class. But that something like that does happen. All right. So let's see. Okay. So if you have h of f equal to if you have, since we have the hf, now let's compute. This time this is 36 x squared y squared, right? And then minus 2 times 2. This times 2. This times this, and that times that. That's how you calculate. So it's minus 4. That's your Hessian. Now let's calculate the Hessian at each point. H of f at 0, 0. That's the first critical number, right? So for each of the critical numbers, the critical points, you have to calculate the Hessian. What's f of h of f 0, 0? Negative. Which is negative, which means?
It's changing.
Relative.
So, 0, 0 is saddle. Now let's do h of f 1, 1. In that case, that's 36 times 1 times 1, so it's 36 minus 4. Which is 32, that's positive. Therefore, now we have to look at what? Negative 6x squared, right? So, fxx evaluated at 1, 1 is, well, that means whenever you see x, you have to replace by 1, and whenever you see y, you have to replace by 1, but there's no y here, so you just replace x by 1. Sometimes you may have y in there too. Therefore, you get what? Negative 6, which is negative. And therefore, in this case, what do we have? Relative maximum. It's a frowning face, so it's a relative max. And then, hf, negative 1, negative 1. Because you're squaring it, you get the same value. Which says that fxx at this number will determine whether it's a relative max or relative min, and we see that it's a relative, it's still negative 6, so it's a relative max. So that means this function has 2 relative max points and 1 saddle point. Now to give you some idea of what's going on for this graph, this is actually a question in our textbook. And the textbook also has a nice graph associated with it. So if you draw it, they say it's like 2 mountains and it's like that. So these are the two relative max, right? And then at this point, there's this is like a saddle. It's like a camelback. So if you put a saddle on a camelback, that's exactly what you see. So this point is the saddle point, and these 2 points are the highest points. Okay. All right. So we should write down the answer. Answer is, well, I guess to finish this question, you should really say if the z coordinates too. 1, 1. If I plug in a 1, you get minus 1, 2, minus 1, plus 1 is 2. So we know that the answer is 1, 1, 2, and negative 1, negative 1, comma 2, both cases you get 2, are relative max, maxima. And what about the relative minimum? There is no relative.
So you got
Oh, Professor.
Yes.
Would you have to apply 0, 0?
No, 0, 0 does not count. The question says find all relative extremes. Sometimes I say find all critical points and figure out the nature of the critical point by using the second derivative test. In that case, you should also include this.
Okay.
But for this question, I said just find all the relative extrema.
Yeah.
So you just find the relative extrema. That's it. Just say that it has a relative maximum. It has 2 relative maxima and no relative. Zachary, you had a question?
I got it.
Oh, okay.
Yeah. Let's see for z.
Oh, I just plugged in 1, 1. See, this means this is the point x, y being 1, 1, right? So you plug in 1 and 1, 1 and 1, and if you go 2, you get 2. That's the value of z. I did plug in 0 because 0, 0 is the saddle point, and saddle point is not a relative extreme. Any other questions?